Okay, this will be the third and final video of our Chapter 2 review. The two others are prior, they're about 25 minutes each, and this may be in about that same range. This represents Monday's portion, the second half of the test, starting from problem 7. 1 through 6 will be on the first half of the test. So we are to find the average rate of change. And if I'm on some curve and I want average rate of change, the average rate of change from here to here I can get just by drawing this secant and just focus in on these two ordered pairs and just find the slope. I just want the slope of the secants. Okay? So I don't even have to look at the graph of this. I want to find out what f of 2 is, and I want to find out what f of 4 is. We realize even if that was in parentheses, it's not an ordered pair of point. It says that the interval 2 to 4. So when f is 2, I am at, and I didn't try to draw, this isn't supposed to represent this curve at all. If it would have, it would have just been coincidental. When I put 2 in, I get 2 cubed minus 1, or 8 minus 1 is 7. So that would be equivalent to having this be 2, 7. Again, I know it's not the same graph. When I put 4 in, I get 4 cubed minus 1 is 64 minus 1, 63. Now, as I'm doing that, this will be a reminder to the other classes. I was going to tip you guys off on this before. For the test, as soon as I did 4 cubed, I'm like, oh yeah, some of you are going to want to do that on your calculator, and that's fine. You may use a calculator on the test. It may not be a graphing calculator. And that's going to sound like crazy because on the AP test you can use a graphing calculator. That I'm doing this for you. Because everything here you're supposed to show me you can do this without, and some of you are going to be able to show me some things on some limits. You're going to be able to do it based on inspection. You're going to say, well, I know the limit of this function as we approach infinity is this. But if I don't see the work behind it, and you have a graphing calculator, now I got to say, did they really understand this concept? So bring a calculator. Trust me, you will not need it. But if you want a calculator that's not graphing and you want to have that with you, you are welcome to have that out. But no graphing calculators. Okay, back to this. So is it clear we got two ordered pairs? I got 2, 7 and 4, 63. The average rate of change is just the slope. Y became 63. It was 7. X became 4. It was 2. I get negative 56 on 2. You want to do that on calculator? Great. Your calculator will help you tomorrow. And that's not negative 56, that's positive 56 on 2. And that is 28. We have a slope of 28. That's the average rate of speed. Doesn't mean that's what the rate of speed the whole time. Here it might be flat and get really steep. Maybe I was going, the average rate of speed on a trip from here to St. Louis might be 65 miles an hour. But it doesn't mean that you got in the car and turned it on and started going 65 instantly. That would not be a good situation. All right? Same thing here. F of negative 1 and f of 1. F of negative 1 is negative 1, all of it cubed. And that's negative 1 minus 1, negative 2. F of 1 is 1 cubed minus 1, 1 minus 1, 0. So my y's went from 0 became 0, started at negative 2. My x's became 1, started at negative 1. I get 2 on 2, or slope of 1. Average rate of change. That's a gimme. That's a nice Monday morning question number 1. Monday afternoon for you guys. Okay, number 8. At the indicated point, they don't even indicate the whole point for me. I got to work for that a little bit. Well, it's not too much work. At x equals negative 1, I've got negative 1 squared 1 minus 1 at this point. Is that okay? I'm going to probably refer to this as f of x anyway. F of negative 1 is negative 1 squared 1 minus 1, 0. So at that point, find the slope of the curve, the equation of the tangent line, the equation of the normal line, plot all three, show all work. You must use the limit process, which means if we're going to be finding slopes, we can't just say, oh, the slope formula for f is 2x. I know it is, but we're going to use the limit process. throughout the test. There's another part of the test where I felt the need to write that as well, because it's really tempting not to. You're going to get to bypass that, but I just don't think you're sick of it enough yet. All right. So I need to get a slope if I'm going to get a tangent line. Maybe I'll go, I got to graph this anyway, so maybe I'll go ahead and graph this. Put in 0, get -1. That is the vertex, just down 1, and then it's a regular old parabola, over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 1, 2, 3, 4, over 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I did up 7 earlier, up 9. My graph wants to look like this. Okay, but this guy is the big player right here, that -1, 0. That's the point that we want our tangent line. Gonna get a tangent line through here, but I'm not going to draw it till I get the equation of it. To get the tangent line, I need to know the slope. What I know about the slope right now is it's definitely negative. There. To find the slope, limit as h approaches 0 of f of x plus h. So that is x plus h, all of it squared, still -1. Almost one word to me now at this point, minus parentheses. X squared -1, all on h. If we don't put minus parentheses there, we ought to catch that mistake in the next step, but let's just get it taken care of in the first step. Limit as h approaches 0, I get, FOIL, x squared. Think it'll cancel? It better. Plus 2xh's. Think it'll cancel? Could, might not. Plus h squared. Think it'll cancel? Probably not. I'll be surprised. Minus 1. Still got my -1 here. Sorry, almost forgot that guy. Then distribute minus x squared plus 1. X squared with one little line through it cancels. -1 with one little line through it cancels the +1. All of this is on h, and now I can reduce by h. So I get limit as h approaches 0 of 2x plus h. And now I'm actually finding the limit by putting 0 in, equals 2x. So my slope formula, or my derivative, is 2x, but I'm not interested in it everywhere. I'm only interested in it at -1. 2 times -1, -2. All right. So down below, I'm going to write my slope is -2, and I'm just going to rewrite down here that my point that we're passing through is -1, 0. Let's take a look at that. I'm passing through here with a slope of -2. That's down 2, right 1, down 2, right 1, or up 2, left 1. That's pretty reassuring. That seems reasonable that that might be the tangent line. Whoops, that's bad. Just trying to continue it up 2 over 1. Is that all right? So I can get the equation from there, but I can also, I got a slope of 2. The tangent line is y minus 0 equals -2 times quantity x minus -1. Because I might want to graph it after getting the equation, I might change this into -2x minus 2, but I can live with that because they don't tell us what form to put it in. But it is kind of reassuring now to look at this and say, y-intercept -2, slope -2. Ooh, that's really nice. Okay. Normal line. For the normal line, I want to use a slope of 1/2. Same point though, y minus 0 equals 1/2 times x minus -1. Or if you like, y equals 1/2 x plus 1/2. And if you do this right and you go to there and now you graph this, don't come here and graph it as the normal line because I know it's perpendicular. Let's just graph this line. Y-intercept 1/2, slope of 1/2. Y-intercept 1/2, slope of 1/2, which is up 1 over 2, or down 1, left 2. That's, I believe that. I believe that that is where we would be. down 1, left 2. Looks pretty good. Is that okay? So everything's really kind of reassuring. Yes, I got the tangent. It looked right there. I worked for this, but it looked right. It looks perpendicular there. All good? All good. Okay. Determine whether the curve has a tangent at the indicated point. Well, this curve has tangents at every point. This curve, which is a straight line, is its own tangent. It is its tangent. But at the point 1, I shift from this to this. So I could come sliding down some curve. I'm not trying to draw x squared plus 3. And then I could get on the next curve, and maybe the next curve jumps up here. There is no tangent line. Or I could come sliding down, hit a curve, stop here, jump on another curve like that, and create this cusp. 2 conditions have to be met for there to be a tangent at 1. We have to meet at the same point, and it has to be not just a smooth transition, it has to be the same slope exiting this curve as I get entering that curve at 1. Those 2 conditions. So I'm going to talk about F1, F2. You can do this kind of thing. You don't have to do this. I'm going to say F1 of x is x squared plus 3. And then I'm going to say F2 of x is 2x plus 2. Pretty clear to the reader what we're talking about. You don't have to do that, but you got to convey the reasoning here. So I'm going to find F1 of 1. That's like my exit point, right? F1 of 1, and I get it, 1 goes here, but 1 almost goes there. I could graph this. We'll talk about that in a bit. I put in 1 and I get 1 squared plus 3 or 4. How about F2 of 1? My entrance point, I get 2 times 1 plus 2, I get 4. Job 1 done. But how do I know that we're not dealing with a cusp here? I have to analyze the slopes. Well, F2, you don't have to go through slope formula here. It's a line. We brought that to this course with us. We know that slope is 2. And I know you guys know the slope formula for this is 2x. Maybe not everybody, because if you weren't honors, you might not know that yet. You still have to go through the limit process. So, limit as h approaches 0, we want the slope of this guy, x plus h squared plus 3 minus parentheses x squared plus 3 all on h, because I just don't think you're sick of it yet. I'm sure you're saying you want to bet. X squared plus 2xh plus h squared plus 3 minus x squared minus 3 all on h. What good happens? This guy better cancel. It did. This guy better cancel. It did. Those guys might. They reduce. Limit as h approaches 0 of reduced by h, 2x plus h. Now put 0 in. F prime of x, our slope formula or our derivative, is just 2x plus 0 or 2x. But I want our slope when x equals 1 for this problem. And that's 2 times 1 or 2. So here was job 1. Here was job 2. I know my sliding board coming down. It doesn't have to be coming down, it could be going up, but I like using sliding board. My sliding board coming down meets my line after it at the same point and continuous smooth on the same in the same direction. Is that okay? So the question is, well, can we just graph this? Well, let's take a look. If we graph this guy, x squared plus 3, 1, 2, 3, only to the left of 1, so I'd be using this point, put in 1, get out 4. My graph looks like that, right? And then I jump on 2x plus 2, so I jump on here, and I do want to come up 2, but I don't start until here, so I'm going up, and we look at that and we say, oh yeah, that's smooth. What I do know is they met at the same point, but how do I know that this slope isn't 1.9 and this slope is 2.03? You see what I'm saying? If this one had looked like that, the graph would be enough to say, hey, no, they are not. It doesn't work. There is no tangent line there. But here all I can say is, oh, I got to do the work. Right? Now, if I'm going through this process and this is 4 and this is 3, you understand, we're done. There is no tangent there. But as soon as that worked, I had to check the second test. Questions there? All right, you guys are going to do great on this. Feel it. Find the slope of the curve at the arbitrary value x equals, this might as well said x equals 2, x equals 7, x equals pi, x equals negative square root of 3. It doesn't matter. At some value, I'm going to find the slope of this. I know it's 2x minus 1, Mr. Hearn, so do I, but I'm going to do it too. You think you're sick of it? I'm doing it 3 times a day for my life. Okay? H approaches 0 of x plus h squared minus x plus h minus 2. The next thing I'm going to write is minus parentheses x squared minus x minus 2. Don't you dare forget that. You'll be really frustrated. All on h. So limit as h approaches 0 of x squared plus 2xh plus h squared. You're probably pretty good at foiling out perfect squares now, binomials. Minus x minus h minus 2 minus x squared plus x plus 2. Let's make sure everything that needed to cancels. X squared needs to cancel. It does. X needs to cancel. It does. Minus 2 needs to cancel. It does. Everything else has an h. Be careful here. Limit as h approaches 0. Because I'll get people that will just say 2x here. 2xh divided by h is 2x. H squared divided by h is h. I'll get that, and then I'll just get that. Minus h divided by h is minus 1. So my slope formula, my derivative, put in 0, is 2x minus 1. Oh yeah, I knew it. I knew it. I told you. Told you I could have done it without doing that. I know. I know you can. Happy for you. Okay. So this is my slope formula. I want my slope at the value a. Well, how hard is that? Well, then f prime of a is 2a minus 1. How could we have reduced that by one step? Use a instead of x here. Just put a in here. Just use a and then you're done here. I could, if I wanted to find the slope at 3, I could have put 3 here instead of x. And then I'm done one step sooner. If I want to do pi, I'm going to put pi there instead of x, and I'm done one step sooner. You know what I'm going to do? I'm just going to get really good at x because I don't mind that next step. All right? Okay. At what points, if any, are the tangents to the graph horizontal? On this problem on the test, I say you must use the limit formula. It would kill me. I'd be like, geez, I know it's negative b on 2a. It's 3 on 2. That's where it happens. That's it. I mean, that's the x value. Because tangent lines are horizontal at the vertex. And where's the vertex? The opposite of b on 2a. But limit, just to keep it fresh, I'll do it in blue. Limit as h approaches 0 of f of x plus h squared minus 3 times x plus h. I need a longer line. Minus parentheses x squared minus 3x, all on h. Limit h approaches 0, x squared plus 2x h plus h squared. Careful, distribute everything. Minus 3x minus 3h minus x squared plus 3x, all on h. Make sure we cancel what should be able to be canceled. X squared cancels negative x squared. Minus 3x cancels plus 3x. Everything else has an h. Limit as h approaches 0 of, reduced by h, 2x plus h minus 3. So f prime of x is 2x minus 3. That's my slope formula. But what do we know about slopes? of horizontal tangent lines? There's 0. So let's make 2x minus 3 be 0. X is 3/2. Shocking that we came up with 3/2 there. Is that the point? That's half of the point. The point is at 3/2 somewhere. Here's where people blow it. 3/2 where? Do I put 3/2 into here, or do I put it into there? Here or there? There. That's going to give me 0. The vertex isn't at 3/2 0, it's at 3/2 this. 3/2 squared minus 3 times 3/2, that's 9/4 minus 9/2. Have you ever noticed when you're finding a vertex of a parabola or completing the square, the second number is always double the first number and always the opposite of? We'll explore that some. This is 9/4 minus 18/4, or negative 9/4. Good? Okay, draw the complete graph. I think I'm going to start there. I am going hunting with a 1, or at 1 with a circle. I kind of like that analogy. I'm hunting with a circle at 1. Put in 1, get out 4. Circle. Everything to the left of there, I'm hunting with dots. Now, I can pick more values to the left, but I know that this is just negative x plus 5. It has a y-intercept of 5, a slope of negative 1. Now, I am hunting at 1 with a dot. At 1, I get 3. And once again, I'm hunting at 1, but back with the circle, put in 1, get out 1 squared 1 plus 3, 4. I'm back here. I'm just going to T-chart this in my head. Put in 2, get out 7. Is that all right? 7. Put in 3, get out 12. I'm above. If I was going to put in 0, I'd get 3. This is just a parabola. It's curving. Doesn't have too much time to curve a whole lot. Looks something like that. There's my complete graph. Okay. Question B. Find the limit as x approaches 1 from the right. So, I am approaching 1 from the right. I'm moving to the right. I'm approaching 1, but I'm on that red curve up here. And as I'm sliding to the right down this curve, if the blinders are on, in my next step, I expect to be at 3 or 4. 4. I'm coming to 4. I get it. It jumps. But if the blinders are on, my next step, I'm going to be, well, move that paper clip, and I'm going to be at 4. So the limit as x approaches 1 from the right of f of x is 4. Don't put limit x approaches 1 from the right 4. Because that's not what they're asking. Of f of x is 4. How about the limit as x is approaching 1 from the left of f of x? Approaching f of x, just sliding down, just on this line, I don't expect to change. I expect to be 4. Sorry, need to have that up. Is that all right? What is the limit as we approach x? Just the plain old limit. Is it, how about fingers, 3 or 4? Well, I'm glad we're talking about this today. 3 or 4? I'm really glad we're talking about this today. The limit at 1 is 4. F of 1 is 3. The limit is 4. That is ET. We're in left-hand and right-hand agreement. That's what a limit is. The limit at a value is what it's approaching from each side. Better be approaching the same thing. What is it approaching from each side? It's approaching 4. That is definition of a limit. I get it. F of 1 is 3. But f of 1 isn't always the limit as we approach 1 of f. What is the limit of f of x? It is 4. Why? And what I really want to say is, didn't you see what I just did here? I just showed that from the right and from the left, the limits were both 4. I'm going to say right and left hand limits at 1 are both 4. That's why. Okay. So we go back up. Those of you who had 3 fingers might be confused on something like this. We might say the limit of this at 2 is 5. No, f of 2 is 5. This has nothing to do with this problem. F of 2 is 5, but the limit at 2 does not exist. The limit from the left is 5. The limit from the right is 2.5, but we're not in agreement. Is that okay? Here we're in agreement. It's 4. It's just interesting that f of 1 is 3. Okay, and this problem is really kind of a disaster. And what makes this problem kind of a disaster, and your number 13 on the test is not even remotely like this. I said they were all the same. It's not, and it's easier, and I'm not going to talk about it. And it's easy. I mean, it's really easy. You will be fine on it. Here's a good hint. If you don't feel you're fine on it, just do what you think you ought to do. All right? But it's not like this. But what makes this one particularly nasty is that one of my variables for my volume of the cone is h. Do you understand that h is not the h we talk about when we slide over h and get another point? I don't want to take limit as h approaches 0. Because that h and this h are 2 different h's. You with me? But there's nothing special about this little value of h here, so I'm going to go limit as a approaches 0. You see the conflict there? Otherwise, I'm going to be combining 2 h's, which mean different things. All right. Now, they're talking about r changing. So r is like my x. Is that okay? So I want r plus a. Pi of r plus a squared h. So they could have said h is changing, and then it would be h plus a. All right. So this one's just different. Minus parentheses. Oh, pi r squared h on 3. Didn't need the parentheses. I want my money back. All on... Oh, wait a minute. This one's on 3 as well. Rats. Sorry, Video Land. This one's on 3 as well. All on a. Is that okay? I'm going to multiply by 3 on 3. I'm going to write kind of small here. Limit as a approaches 0, I get pi r plus a squared h minus pi r squared h all on 3a. Let's see what happens. Limit as a approaches 0. I'm going to put the pi and the h all to the left here. Pi h times, FOIL this, r squared plus 2ra plus a squared minus pi r squared h. I'm going to do this just for space. All on 3a. Let's see what happens here. I get limit as a approaches 0. Oh, this is going to get ugly before it gets good. Pi h r squared plus 2 pi h r a plus pi h a squared. Remember when math used to be about numbers? We got one number so far, I guess exponents. Minus pi r squared h, all divided by 3a. Yay. Cancel, cancel. Reduce by a. Limit as a approaches 0. Reduce by a, I get 2 pi hr plus pi ha, but I want a to be 0, so that leads me to my formula of just, when this is 0, I just get 2 pi HR. Whew. Right? Cancel the A's, put 0 in for A. This is gone. 2 pi HR. That's my rate of change based on R. What do I mean? Oh, the 3's still there, isn't it? On 3. On 3. I put it up top. Thank you. Thank you for the puzzle book. The A cancels, but the 3's still there. So now I want to find out when the fixed height, the cone with fixed height 4, as R approaches 3. I want R to be 3. So as R equals 3 with the fixed height 4, I get 2 times pi times 4 times 3 on 3. And I get 3's cancel, I get 8 pi. Okay. Now, nothing like that whatsoever. I want to show that problem anyway. It's nothing like that. If you get to that one, you'll know what you're doing. If you don't, what you think you should try will work. If you don't know what I'm talking about now, you will when you see that test. Okay, so that is Monday's portion. For those of you that are looking for tomorrow's portion, those are done on videos. We did not do those in class.